This lesson shows how to solve conjunctions, compound inequalities joined by the word and. Solve conjunctions by solving each of the two parts. For this example, on the left, you have 5 is less than 2x plus 15. Subtract 15 from both sides, for negative 10 is less than 2x. Then divide both sides by 2, for negative 5 is less than x. This is backwards, so turn it around for x greater than negative 5. On the right, divide both sides by 6 for x less than 3. So the solution is x greater than negative 5 and x less than 3. What this means is any number between negative 5 and 3 is a solution. When you write a conjunction, the left-hand inequality must be greater than, and the right-hand inequality less than. The number on the left must be smaller than the number on the right. There are two boundary checks. On the left, rewrite the inequality as an equation and substitute the left boundary, x equal negative 5. Then 2 times negative 5 is negative 10, and negative 10 plus 15 is 5. And the left boundary checks. On the right, rewrite the inequality as an equation. Then substitute the right boundary, x equals 3. Then 3 times 6 is 18, and the right boundary checks. There's also an inequality check. Select a convenient value in the interval between negative 5 and 3, like x equals 2. Then rewrite the inequality, substitute x equals 2, and simplify. On the left, 2 times 2 plus 15 is 19, and on the right, 6 times 2 is 12. Then, since both statements are true, the inequality checks. When you're solving inequalities, it's important to graph and check your solutions to verify that they make sense. For example, this solution is written backward because the less than inequality is written first. If you turn it around, you have a good statement. All numbers greater than negative 1 and less than 4 are the numbers between negative 1 and 4. Here's an example of a solution that's no solution. To see why this is true, graph each part of the conjunction x greater than 3 and x less than negative 2. These two graphs do not overlap or intersect. There aren't any numbers that make both statements true. So the solution to this conjunction is no solution. Here's an example of a solution where both inequalities are the same. They're both greater than inequalities. To determine the real solution, graph each of the inequalities, x greater than negative 3 and x greater than 2, and find the part of the number line they share in common. A number like negative 6 doesn't make either statement true. A number like -1 makes just the first statement true, but a number like 4 makes both statements true. So the real solution is x greater than 2. Only numbers greater than 2 make both statements true. This lesson showed how to solve conjunctions, compound inequalities joined by the word and. And this lesson was brought to you by the Math Fun Academy. Its continuing mission: to explore strange new worlds, to seek out new math and new equations, to boldly go where no math student has gone before.